Good morning, Cédric.
Hi.
Can you tell us what's your background, please?
Yes, sure. My first interest was in physics, actually. I did a PhD thesis in astrophysics. But then at that time I was lucky enough to travel a lot all around the world, and I discovered some ecosystems, wonderful ecosystems. I really wanted to understand them and try to improve our understanding in order to better manage them. So that was my first reason for going to environmental sciences.
Okay, and you often talk about social-ecological systems, but can you explain us what it is, please?
I used to represent it as a hand. An ecosystem is a bit like my hand, in which you may find some fauna, some flora, some soil components, atmospheric components, and humans. And what we want to understand is not only a finger or two fingers interacting between each other, but rather the hand itself, the whole hand. And this we cannot today. We are not yet able to understand the ecosystem as a whole. And this is why we try to build some models to do it.
And so do you sometimes use physics methods in the ecological models that you build?
Yes, good point. The first time I tried to do it, I came to ecologists and I proposed them kind of a time series analysis, kind of a spatial analysis. And gradually I shifted first from remote sensing, then in hydrology or climatology, and ultimately in ecology, where since this time I'm building some models, and they are directly inspired from physical methods.
All right, so what kind of models are those that you're actually talking about?
We use a family of models which are called discrete event models, because the states of the system we are modeling are discrete and there are some transitions between them. So we use a graph representation similar to the hand I was explaining a while ago. We use the graph to represent the different components of the system. These components are the nodes or the vertices of the graph, and they are connected through edges which are representing the processes involved or involving these components.
Okay, so can you explain us what are the purposes of making such models?
Actually, in terms of purposes, there are several. Because the first one is to integrate the knowledge we have and what we understand on this ecosystem that we study. But the main one is rather to be able to mimic the system in the model and then query the model. We would like to question some questions about the management, about its possible future, and then to see if it may occur or not. There are several projects ongoing and future projects. For example, one of them consists in developing similar models on different sites and be able to provide some foresights by the use of these models, which are qualitative, discrete, and in order to provide some foresights in the near future and help anticipate some possible unwanted directions or trajectories.
Another point now, I've noticed that in your model you attribute an important place to humans in ecosystems. Well, can you tell us more about it, please?
Humans are very important in ecology as well, because as I explained, they are part of the system, and they are also continuously interacting with non-human components. And so what we need to do in order to better understand such social ecological systems, is to understand the role played by humans in the system and their interactions with the other components. So we need to improve this, and this is why we are often collaborating with sociologists and economists, politicians, in order to improve our knowledge of their actions, their activities in the system.
Okay, so we can find a part of your studies in the book that you recently wrote, The Languages of Nature. Well, I would like to understand what kind of link can you make between the languages and the ecosystems actually.
Yes, that's a good point. Okay, my proposal is that in this recent theory I've proposed is that there are languages all around us, and in particular in ecosystems. The idea or the working hypothesis is that there is a language which is functioning the system and which we need to decode, to identify, and then possibly use it in order to answer to the questions I was talking about. And the idea behind the language is that you have a vocabulary, which are precisely the components of the system, and kind of grammatical rules that are combining or assembling these components to for making functioning the system. And so we try to identify the vocabulary and then the grammar which is behind such a language.
All right, so tell me if I'm wrong, but those languages, is that what you model?
Exactly, yeah. But there are two levels, because when you model the ecosystem by using our approaches, in a way you are trying or testing some kind of languages. But there is a second level which suggests to study the language itself and look for some properties, because these different languages, be it the language of an ecosystem, of a cell, or of an organism, living organism, are different in a way. And these are these differences that we try to identify. We make it according to their properties. Some languages have specific properties, and other languages have other properties. This is a second level, a more theoretical level, to analyze these languages.